Welcome to The Explainer. Today we're going to tackle a core concept in test automation that really separates brittle, frustrating scripts from truly robust frameworks. It's all about getting your code to work a lot smarter, not harder. I mean, we've all been there, right? Especially when you're just getting started. You build something that works absolutely perfectly for one specific situation until, of course, the requirements change and the whole thing just falls apart. Okay, let's dive into this with a really common, real-world Selenium example. We're going to watch a simple, well-intentioned script spiral into a maintenance nightmare, and then we'll discover the elegant solution that fixes it for good. So when we first start writing a Selenium test, the code is usually beautifully simple. All we're trying to do is open up a Chrome browser and get it to do something for us. You write this one line, you're directly creating an object specifically for Chrome. And then, bam! You can immediately start using methods like .get to navigate to a website. It's direct, it's easy to understand, and hey, it works. But then, you knew it was coming. Sooner or later, someone from the team comes along and says, "This is great! Now we need to run the exact same tests on Firefox too." And your first thought might be to just comment out the Chrome line and swap in a new one for Firefox. And look, for a quick one-time test, that works. But this is not a scalable, and it's definitely not an automated solution. You can't be sitting there manually changing your code every single time you want to switch browsers. Okay, so plan A is out. Let's try to get a little bit clever. We can use an if-else statement to pick the browser based on some variable, maybe something we pull from a config file. This feels like a step in the right direction, right? And error. It breaks immediately. So what's going on here? See, the driver variable is being created inside the if and else if blocks. That means its scope, its whole world, is limited to just those curly braces. The second the code moves past that if block, that driver variable just vanishes. It doesn't exist anymore. It's a classic scope problem. Okay. Attempt number 2. We know scope was the problem, so let's just declare the driver variable outside of the if blocks, make it global. Now the scope issue is solved. If our browser string is Firefox, the code creates a Firefox driver, assigns it to our global variable, and it works perfectly. We're back in business. But here's the real test. What happens when we go into our configuration and just flip that one little string from Firefox to Chrome? We run the exact same code. The else if block should handle it no problem, right? Nope. Total disaster. You get a null pointer exception. And here's the really weird part. You'll actually see a Chrome browser window pop up on your screen for a split second, and then the whole thing just crashes. So, what in the world went wrong? Okay, let's break it down. The whole problem starts with our global variable. We declared it as a Firefox driver. It's like we created a box that can only hold Firefox objects. So when our logic hits the Chrome block, it does create a Chrome driver, but it can't assign it to our global variable. It's the wrong type. That means our global driver variable never gets a value. It just stays null. And the moment your test tries to call a method on null, that's a crash. At this point, the only path forward seems absolutely terrible. We could create a separate global variable for every single browser and then, duplicate our entire test script for each one? That's a complete maintenance nightmare. It's the definition of bad code. There has to be a better way. And thankfully, there is a much, much better solution. The answer lies in a fundamental programming concept called an interface. And in the world of Selenium, the most important one you need to know is called WebDriver. So what the heck is an interface? Just think of it like a contract, or maybe a blueprint. It's just a list of rules. It says, hey, any class that wants to be one of me must provide these abilities. It defines the what, like having a .get method or a .click method, but it leaves the how up to each individual class to figure out on its own. Honestly, the perfect way to think about this is a universal remote. The WebDriver interface is the universal remote. The methods like .get, .click, and .quit are the buttons on that remote. Power, channel up, volume down. And the different classes, Chrome driver, Firefox driver, they're like your different brands of TVs. They are completely different on the inside, but they have all agreed to follow the universal remote contract, so the same power button works on all of them. It's brilliant. So now that we have this universal remote concept in our heads, we can go back and refactor our messy, broken code into something that's clean, flexible, and honestly, the professional way to do it. And this slide right here is the whole ball game. On the left, you've got our brittle code, a nightmare of specific variables. But on the right,
Look at the single most important change. Our global variable is no longer a Firefox driver, it's just a WebDriver. It's our universal remote. This one variable can now hold an object of any class that implements the WebDriver interface. That means our test code only ever has to be written one time.
So the logic becomes incredibly simple and clean. You declare one universal remote. That's your WebDriver variable. Then you use your if-else logic to create the specific TV you want to use, whether it's a new Chrome driver variable or a new Firefox driver. You assign that TV to your remote. And from that point on, you just use the buttons on the remote. They'll work no matter which browser you've chosen. So what's the big takeaway here? Why is this more than just some clever coding trick? Well, this concept right here is the fundamental building block that lets you go from writing simple scripts to building real, scalable, professional automation frameworks. Because using the interface makes your whole test suite manageable. A new browser comes out, you just add one more else-if block. You don't have to touch any of your hundreds of existing tests. You find a bug in a test case, you fix it in one single place, and that fix instantly applies to every browser you support. It's just a game changer. And this idea of a common interface for different things is everywhere once you start looking for it. Think about USB-C, one cable, one interface that works for your phone, your laptop, your headphones. Or think about SQL, which is a standard language you can use to talk to many different types of databases. Thinking this way in terms of contracts and universal standards is a huge part of becoming a more effective engineer. I hope this helps you build better, more robust tests. Thanks for watching.